Good morning, student. Today chemistry class. The lesson name is metals and non-metals. Okay. Today last class we were learning about metal lessons. Metal react with water, physical property of waters, physical properties of metals, and chemical properties of metal. Particularly chemical property, metal react with the air or oxygen. Now today class, metal react with the acid. Metal react with the acids. Very interesting topics. So generally, already studied in the 8th standard. Generally, metal react with acid to evolve or liberate hydrogen gas. To liberate very vigorously, hydrogen gas is liberated to form metal salt. That is metal react with acids to form salt. To form salt formations and liberate hydrogen gas. Hydrogen gas is liberated. Hydrogen gas is liberated to evolve hydrogen gas. This is one of the displacement reaction. This reaction is known as single displacement reaction. Single displacement reaction. Single displacement reaction. Metal react with acid to form metal salt. That is a metal salt. That is a salt and liberate hydrogen gas. That is a metal react with acid. Metal react with acid to form salt and hydrogen gas is evolved. Hydrogen gas is evolved. Hydrogen gas is evolved. Now you see the activities. This activity is in textbook, page number 44. This activity is present in page number 44. This activity I will explain this. Broadly explain this activity. You take a 4 test tube, A, B, C and D. You take a 4 test tube. In a test tube A containing acid, dilute acids, hydrochloric acid, equal amount of dilute acids. In test tube B, so dilute acids, hydrochloric acid. Test tube C, dilute HCl acid. And test tube D, dilute hydrochloric acid. Equal amount you will take. Equal amount of, say example 10 ml. Sorry, 5 ml you take. 5 ml of hydrochloric acid. Dilute acid. Now, in a test tube A, you add magnesium metal. Magnesium metal, ribbon. Magnesium metal, pinch amount of or small amount of magnesium metal you add. So this metal is react vigorously to evolve hydrogen gas, to liberate hydrogen gas very quickly liberated. Then test tube B, you take a test tube B, hydrochloric acid, you add aluminum metals. This is aluminum metals you add. Aluminum metal is added. And this aluminum react with the hydrochloric acid to evolve hydrogen gas. Comparing test tube A, B is less reactive. Less amount of hydrogen gas is produced. Then test tube B, the same amount of hydrochloric acid. Then zinc metal is added. So react very moderate reactive to evolve hydrogen gas. Now test tube D, that is the amount of HCl. You take same amount, where iron metal and evolve hydrogen gas very least amount comparing C. Now how can you test evolve hydrogen gas, whether the gas are hydrogen or any other gases? That is hydrochloric acid. Say example, you add zinc metals. What happens? So hydrogen gas is evolved. How can you test whether the gas hydrogen or oxygen or carbon dioxide or hydrogen dioxide? Very simple. One for test for hydrogen gas. Test for hydrogen gas. Whether you burning matchsticks. You take a one match sticks, burning match sticks. Burning match sticks. Its close come to the mouth of the test tube. Its closely come to the mouth of the test tube. This is the mouth of the test tube. This match sticks, burning match sticks. Burning match stick. Burning match sticks. What happens? To produce the, when burning match sticks near the mouth of the test tube, this hydrogen gas contact with the flame fire, that is to produce the sound. That is a pop sound. This sound indicating test for hydrogen. Pop sound. Pop sound is produced when burning match sticks near the mouth of the test tube. Hydrogen is released in this reaction. You burning the match sticks near the mouth of the test tube to produce the pop sound. That sound indicating whether the gas, hydrogen gas present. The gas is a hydrogen gas is a present. Okay. Now that's all. Next, and the same activity but highly reactive metal. Highly reactive metal, what's the metal? Sodium. Sodium, potassium. This is a highly reactive metal. This metal is a twins metal. Twins metals. This metal is kept in the kerosene or stored in as kerosene. This sodium and potassium is stored in a kerosene because it's a highly reactive metal. Because highly reactive metal. This box, this is a kerosene. Kerosene, sodium metal, piece of sodium metal is present. Sodium or potassium. Sodium or potassium. Sodium or potassium is kept. But lithium metal stored in paraffin oil. Paraffin oil. Okay, that's it. Now what happens when sodium metal is a highly reactive metal? This is a highly reactive metal. Sodium and potassium is a highly reactive metals. When sodium metal is added to the hydrochloric acid, dilute hydrochloric acid, it's a violent reaction takes place or vigorous reaction, very fast reaction, and very fastly hydrogen gas is releasing. Huge amount of hydrogen gas is releasing. It's a highly reactive metal. This is a highly reactive metal. This is a highly reactive metal. So maximum amount of hydrogen gas is releasing. Hydrogen gas is releasing. Okay. Now I will write the equation for all the reactions. All the reactions I will write the equation. First magnesium. First sodium we take. Highly reactive metal is react with hydrochloric acid, dilute to form NaCl plus hydrogen gas is released. Hydrogen gas is released. First. Second equation, potassium. Potassium react with hydrochloric acid to form potassium chloride and hydrogen gas is released. Hydrogen gas is released. Third. Now come to this magnesium. Magnesium react with hydrochloric acid to form salt, magnesium chloride salt, and hydrogen gas is evolved. Hydrogen gas is evolved. Now third one is aluminium. Fourth one is aluminium. Thus, aluminium metal is react with hydrochloric acid to form aluminium chloride and hydrogen gas. To form aluminium chloride and hydrogen gas. Now fifth, what is after aluminium? Zinc. zinc react with HCl to form salt, zinc chloride salt plus hydrogen gas which we have got. Plus hydrogen gas is evolved. Now final iron react with hydrochloric acid to form iron chloride salt and hydrogen gas is evolved and hydrogen gas is evolved. This 6 reaction is a very important. It's not there in the textbook. It's not there in a textbook. Please mention this. Okay, that is a metal generally react with acid to form metal salt and hydrogen gas is evolved. Hydrogen gas is released. How can you test the gas? When the gas burning mass sticks near the mouth of the test tube to form pop sound, that is indicated hydrogen gas. Okay, here 6 metal does not equal reaction rate is not possible. So different type of reaction, different rate of reaction. One is a very fast reaction, another one is a very slow reaction. Another one fast, another very slow. Here very fast. This is sodium because highly reactive metal. This is a violent reaction takes place. So it is a highly reactive metal, that is a sodium. Then sodium, particularly first potassium, then sodium. In this 2 reaction, potassium highly reactive. Potassium is a highly reactive, but more or less same. But in the same highly reactive is a potassium. So potassium. Then next reactive highly reactive sodium. That is a sodium. Then next magnesium highly reactive. Comparing aluminum, zinc and iron. Then after magnesium highly reactive is aluminum. Then next reactive aluminum. Then zinc. Then iron. Then iron. But in your textbook, this reaction, this sequence is given. But this is also correct. This is also correct. So potassium is a highly reactive. Potassium is a highly reactive. Potassium is a highly reactive. Potassium highly reactive. Then first reactive, highly reactive. Then sodium. Highly reactive. Then sodium. Then magnesium. Next reactive, very least reactive. Compare. Aluminum 4th. Comparing magnesium, aluminum least reactive. Zinc is a 5th. Comparing aluminum, zinc least reactive. This is a 6th. Comparing all 4 metal, 5 metal, potassium, sodium, magnesium, aluminum, zinc. Iron is a very least reactive metal. Iron, very least reactive metal because it's a react with hydrochloric acid, very slowly react hydrogen gas. But potassium react with hydrochloric acid, very violent and very huge amount of hydrogen gas is released. But iron reactive very less. Okay, that's all. Now this is a hydrochloric acid react. Now metal react with the sulfuric acid. Next metal react. Here I will write hydrochloric acid. The same metal react with the sulfuric acid. It's not there in textbook. You mention this sulfuric acid. First sodium react with sulfuric acid to form sodium sulfate and hydrogen gas. Second, potassium react with sulfuric acid to form potassium sulfate plus hydrogen gas. Then fourth, magnesium plus sulfuric acid to form magnesium sulfate plus hydrogen gas is evolved. Plus hydrogen gas is evolved. Now fourth one is aluminum. Aluminum react with sulfuric acid to form aluminum sulfate plus hydrogen. That is aluminum react with sulfuric acid to form aluminum sulfate and the hydrogen gas is evolved. Hydrogen gas is evolved. Then zinc. Fifth equation. Zinc react with sulfuric acid to form zinc sulfate and hydrogen gas is liberated or evolved. And sixth one is iron. Iron react with sulfuric acid to evolve ferrous sulfate and hydrogen gas is evolved. This is a ferrous sulfate. What is the color? Green color. Green here. This is a sodium react with sulfuric acid to form sodium sulfate salt and hydrogen gas is evolved. This is a metal react with acid. Potassium react with acid. Sulfuric acid to form potassium sulfate and hydrogen gas is evolved. Magnesium is a metal react with acid. Sulfuric acid to form salt, magnesium sulfate and hydrogen gas is evolved. Aluminium is a metal. It's a react with sulfuric acid to form aluminum sulfate and hydrogen gas. Zinc react with the sulfuric acid. React with the sulfuric acid to form zinc sulfate and hydrogen gas. Iron react with sulfuric acid to form ferrous sulfate and hydrogen gas. So in this all this metal react with the acid to form salt and water and hydrogen is liberated. Hydrogen is liberated. So this is a metal react with the acids. Particularly this metal react with the acids, but this acid cannot react, cannot evolve hydrogen gas. Metal thus react with nitric acid does not evolve hydrogen gas. So metal does not evolve hydrogen when react with the nitric acid. When react with the nitric acid. Reason, what is the reason? Nitric acid is a strong oxidizing agent. Oxidizing agent. This strong oxidizing agent, what is the work of this oxidizing agent? First, generally react with the hydrogen gas is evolved, but this nitric acid, hydrogen evolved is oxidized to water molecule. Is oxidized to water molecule. Hydrogen is oxidized to water molecule. This nitric acid is reduced to nitrogen oxides. Nitric acid is reduced to nitrogen oxide, NO, nitric oxide, NO to nitrogen dioxide, N2O, nitrous oxide. So it's a strong oxidizing agent. What is the work of this acid? These are acid work. When metal reacts with nitric acid, generally it is released hydrogen. But this nitric acid acting as a hydrogen or hydrogen is oxidized to water molecule. So it does not evolve hydrogen gas. Hydrogen gas. Say example, you see. One great example, iron. Iron react with the nitric acids. Generally, what is this? Is a metal. General term. What is a general? Metal react with the acid to form salt and hydrogen. Here, hydrogen is not found in this reaction because it's an oxidizing agent. First, what happened? Iron react with the nitric acid. Iron react with the nitric acid to form FeNO3 tries. FeNO3 tries plus this nitric acid is reduced to nitrogen monoxide. Nitrogen monoxide is reduced and hydrogen found, that is water is formed. Water is formed. So generally react with hydrogen. This nitric acid acting as a hydrogen oxidized to water molecule. Is oxidized to water molecule. Is oxidized to water molecule. So this is a does not produce the hydrogen gas. Hydrogen gas. But exception is there. Some exception. That is a very great exception for hydrogen release. Very great exception, that is a magnesium and manganese is a great exception. It react with hydrogen. It react with as a dilute condition. Magnesium and manganese react dilute nitric acid. React dilute. Very dilute condition. Very dilute condition. Very dilute condition is release hydrogen gas. Is release hydrogen gas. Say example. Magnesium react with dilute acid. Very dilute acid. Very dilute acids. Very dilute acid to form salt. NgNO3 twice plus hydrogen gas is releasing. Plus hydrogen gas is releasing. Another example, manganese react with dilute acid. Very dilute acid. Very dilute acid to form magnesium nitrate, manganese nitrate plus hydrogen here. So these two metals, very important concept here. Magnesium and manganese react dilute nitric acid, very dilute nitric acid to produce the evolve the hydrogen gas. This is the exception cases. This is the exception cases. All the metal react with the nitric acid does not produce the hydrogen gas. But except magnesium and manganese is react very dilute condition to produce the hydrogen gas. To produce the hydrogen gas. That's all. Then next topic, aqua regia. This is not evolved in textbook. It's not evolved in textbook, but aqua regia. Aqua regia. What is the meaning of aqua regia? This is another name is royal water. This is another name is royal water. It's a very important acid. Aqua regia is a very important acid. It's a combination of two acids. Combination of two acids is known as aqua regia. That is HCl plus HNO3. 1:3 ratio. 1:3 ratio. 1:3 ratio. 1:3 ratio is known as aqua regia. What is the use? It's a very highly corrosive nature. Highly corrosive. What is the uses? Gold and platinum. Gold and platinum only dissolve in aqua regia. Gold and highly precious metal, gold and platinum only dissolve in aqua regia. Aqua regia, that is a highly corrosive royal water. This another name is royal water, that is aqua regia. Only gold and platinum only dissolve in aqua regia. That's the reaction. You see, gold plus HNO3 plus HCl. This acid, combination of acid is known as aqua regia. What is the ratio? This is 3:1 ratio. 3:1 ratio. This is ratio aqua regia. This is known as aqua regia. The gold is dissolved. The gold is dissolved to form arid gold chloride minus the charge to form NO plus H3O plus H2O. So this gold completely dissolved in aqua regia. Completely dissolved in aqua regia. Gold completely dissolved in aqua regia. What is the ratio? 3:1 ratio. 3 part nitric acid, 1 part hydrochloric acid. It's a combination of these two acids is known as aqua regia. When gold dissolved in aqua regia to form salt. That's all. Next topic. Metal react with other salt solution. Metal salt solution. metal react with other metal salt solution. That is a single. This is a single displacement reaction. The reaction single displacement reaction. Single displacement reaction. Single displacement reaction. That is known as, suppose metal A, you take any one metals, that is a metal A, salt solution of metal B, salt solution of metal B is a react to form salt solution of metal B, salt solution of metal A, salt solution of metal A plus metal B. Here displacement takes place. Displacement takes place. Okay. Now it's an activity. It's a great activities. Okay. You take your own test tube. Test tube A, test tube B. In a test tube A containing copper sulfate solution. Test tube A containing copper sulfate solution. Copper sulfate solution. Copper sulfate solution. Then test tube B, ferrous sulfate solution. Ferrous sulfate solution. Is not there in the textbook? Okay, do it. No need. The copper sulfate solution. What is the color? Blue color. The copper sulfate solution is what is the color? Blue color. That is known as blue vitriol. Copper sulfate is a blue vitriol. Blue vitriol. Then you add iron A. Ironate. This is the ironate. Ironate, that is a ironate. It's kept in 1 hour or 2 hours, particular time is don't disturb. What happens? The color of blue color of copper sulfate changes into the green color. That is a green color. Reason now, what is the reason? Iron react with the copper sulfate. Iron react with the copper sulfate. The displaced copper by iron, because iron is more reactive than copper. Iron is more reactive than copper to form ferrous sulfate. To form ferrous sulfate and copper metal. Is a copper metal deposit on the surface of the iron layer. Copper metal deposit. Brown color copper metal. After 1 hour, so this is a metal A. This is a metal A. Salt solution of metal B. Metal B. This is a metal B salt solution. Now this is a metal A. B. Metal A salt solution. Metal A salt solution. This is a single displacement reaction. This is known as single displacement reaction. This reaction is a single displacement reaction. Okay. I will do it another activity. It's a reverse side. This activity, reverse side, you take a 1 test tube, you fill it with ferrous sulfate. You take ferrous sulfate, this reaction, opposite reaction, ferrous sulfate, you add copper rod, copper rod. This is a copper metal. Reverse reaction. This is copper plus ferrous sulfate, aqueous solution. This not possible. This reaction is not possible. This reaction is not possible. This reaction is not possible. Reason. What is the reason? You consider this copper iron metals. In this reaction, copper is the least reactive. Iron is the most reactive. So least reactive metal does not displace highly reactive metal. Salt solution does not displace, because already this is a weak, but this is a strong. But in this reaction, most reactive metal displace least reactive. This is a least reactive metal. This is possible. This is not possible. This is not possible. Okay, that's all. Okay, that's all. Next, reactivity series. Next topic here. Reactivity series. Reactivity series. Okay, metals arranged in increasing order of reactivity. Increasing order of reactivity. The reactivity series is the reactivity series of the metal. Reactive series is a list of metal arranged in the order of the decreasing activity. Decreasing activity. That is, metals are arranged in decreasing order of reactivity. In decreasing order of reactivity. Okay, I will arrange the reactivity series. You see, consider this: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead. Then hydrogen. Then hydrogen. Copper, mercury, silver, gold. Here, top to bottom. Reactivity decreases. Particularly, you see, potassium, most reactive metal. Gold, very least reactive metal. Very least reactive metal. Very least reactive metal. Very least reactive metals. I will arrange in a horizontal way. Here, highly reactive metal. What is a highly reactive metal? Potassium. A highly reactive metal, potassium. Then potassium, then sodium, then calcium, then magnesium, then aluminum, zinc, iron, then lead, then copper, then mercury, silver, gold. Here don't use the hydrogen. Why here hydrogen is used? Why here hydrogen? Hydrogen is a gas, but we are using. Why? I'll later tell you. Above the hydrogen, what is above the hydrogen? Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, reactive metals. These are reactive metals above the hydrogen. This is a border. Hydrogen is a border. Below the hydrogen, least reactive metal. Or reactivity 0 is reactive metal. So above the hydrogen, highly reactive metal. Above the hydrogen, highly reactive metal. Which metal? Potassium first, second sodium, third calcium, fourth magnesium, fifth aluminum, zinc, then sixth, seventh iron, eighth lead. Then this is a below, this is a above hydrogen. Now below hydrogen, this is a below hydrogen, copper, mercury, silver and gold least reactive metal. Least reactive metal. Okay. My question is, why hydrogen is placed in a reactivity series? Because it is not a metal, but we are placed in a reactivity series. Because the reason, what is the reason? Hydrogen, first already the lesson started. Okay, definition. What is the meaning of metal? Metal definition: the losing electron to form cation is known as metal. To form cation is known as metal. To form cation. Here hydrogen also, the electron is losing to form cation. So this is a metallic character. That is losing of electron. Metal definition, obeying the metal definition. So this is the border. Insert the hydrogen gas. Insert the hydrogen. So above hydrogen, it's a highly reactive metal. Below hydrogen, least reactive metal. Least reactive metal. This is a reactivity series. This is a reactivity series. Okay. Then today class is over. Next class we will discuss next how do metals or non-metal react, and only two topic is there. How do metals and non-metal react? How do metal? How every metal react? Non-metal. How do you react? Then properties of ionic compound. Properties of ionic compound. Only two topic is there. Only two topic is there. One is the how do metals and non-metal react. Second one is properties of ionic compound. Properties of ionic compound. Two topic is there. Two topic is there. Okay. Then we will discuss, after finishing the two topics, we will discuss about the board questions. Board papers and MCQ others are right. After the topic properties of ionic topic, occurrence of metal, metallurgy is a deleted portion. This is a deleted portion. It's not asking the board exam. It's not asking the board exam. That is a deleted portion. Okay. Okay. Today we will over today class. Next we will see the next topic. Two topic you will see. Okay. Thank you, children.